Okay, I think I'm live. Can someone in the chat confirm if I'm live? Okay, we still have system testing going on. Okay, cool. Let me just parse all the problem in the meanwhile. Also, let me know if the audio is clear. Okay. Okay, I see many people watching today. That's probably because of the contest. Okay, I see no confirmation if anybody can see me. Or yes, sir. Ishank says yes, sir. Live, live. Okay, cool. Okay. Also for the audio as well, is my audio clear or do I need to increase the gain if you feel like it's a little low? In the meanwhile, I'll open the problems. Clear, clear. Okay, Arpit says clear. Okay, perfect. Okay, these are the problems and let me copy paste the solutions. It's clear. Okay, perfect. Okay, cool. Okay, I would like to know like how many people were able to solve like how many questions today. And considering today's contest was a little like different audio, video, screen presenting all clear. Okay, perfect. Thanks, Ritik. Okay, I myself got many wrong answers today. Okay, so everything. Okay, cool, cool, cool. Perfect, perfect. Thank you. Okay, let's start. Okay, I'm just pasting all my solutions so that I can show them to you. Okay. Ishank says only A and B. That's good. If you're able to solve B, that is good. Yes says 1. He says 2, 3 only. 3 is not. How come 3? Like, okay, I think you were able to solve C1 using an n square approach. Okay, cool. Ritik says 0. Okay, no problem. Okay, cool. So let's not waste much time and I'll quickly like tell you about Unacademy and who I am. So basically, I am working in Adobe right now as a software developer. Before this, I was working in DShaw as a member technical. I used to be a CM on Candid Master on Codeforces. Right now, I myself am an expert. Apart from this, I am 5-star on CodeShift, and these are the batches that Unacademy has launched. Okay, so as you can see, like this video that I'm doing right now is a free class. Okay, I do many free classes on special classes also, which is nothing but Unacademy's platform. On there we also have plus subscription. What that subscription gives us is that it gives access to all the batches. Okay, so right now in May we launched 4 batches. One is an interview batch, the other is Samurai, Adroit and Gladiator. So you can just quickly check them out, like what they are, and if you feel like these are the right things for you, you can go ahead and take the subscription. These are the plans of every like batch. These are some of the educators who will be teaching you, and this is a subscription plan. Obviously, as always, you can use my referral code, which is NBYT, and this will give you an additional 10% discount. Okay, so I hope this is clear and everybody knows about this by now. Okay, now let's get to the problems. Okay, okay, just a second. Codeforces. Okay, cool. So we are going to solve A, B, C1 and C2 today. Okay, and okay, I have some comments. Sir, in which college you were? I used to be in JIT Noida, Sector 62. Ritvik says, I actually felt B was really easy for a B level. Ritvik, there were many things, like there were a few things involved in B. So maybe if you got your answer right in the first try, you felt it easy. I got many wrong answers. Let me just show like how many wrong answers I got. I myself got 3 wrong answers and then I got accepted, and that too like at the very end of the contest. Okay, how to be good at A and B since I wasn't able to solve both anyone. I think Piyush, you need to do a little more practice. Okay. Anyways, let's start with the problems. We'll quickly cover the problem A, which is a very easy problem, and then we'll go into B. Okay. So problem A says that you're given an array A of 2 distinct integers. You want to rearrange the elements of the array in a circle such that no element is equal to the arithmetic mean of its neighbors. So basically, the question says that we're given a circle and an array of numbers. So let's say we have A1, A2, A3, A4 till AN. Okay. what we need to do is we need to arrange them. Let's say A1 is here, A2 is here, A4 is here, A5 is here, AN is here, and so on. So we need to arrange all these numbers in a circle such that, let's say there is A6 here, such that the mean of the neighbors is actually not equal to the center value. So basically, if this is like, let's say the permutation that we apply is B, then this is B1, this is B2, this is B3, then B1 plus B3 by 2 should not be equal to B2, and so on for the complete circle. Okay, now I hope the problem is clear to everyone. Okay, now let's go and try to like see. So basically, if you see, there is a very easy approach to solve this problem. What you can do is, I think there must be many ways to solve this problem, but I am going to tell the simplest solution. So what you can do is you can actually sort all the values. Okay, after sorting, what you need to do is, if this was my circle, what I'll do is I'll place my A1 here. Okay, and then I will place my AN here. Then I will place my A3, A2 here, and then I'll place my AN minus 1 here. Then I'll place my A3 here, and then I'll place my A of n minus 2 here, and so on. So basically, I take my smallest value, then my largest value, then my second smallest value, and then my second largest value. Now, the reason why I'm doing this is because, let's see for this, A1 plus A2 by 2 should not be equal to AN. Now see, A1 is the smallest value, A2 is the second smallest value. Therefore, the mean of this is actually going to be lie somewhere. It is going to be greater than A1, and it is going to be less than A2. Greater than equal to and less than equal to. Okay. But we know that AN is the highest value. This is the highest value. That means AN is actually greater than A2. And that means this value is never going to be equal to the mean. Similarly, if we consider this case, we have AN plus A of n minus 1 by 2. Now this value is actually going to be greater than equal to A of n minus 1 and less than A of n. This A2 we know is the second smallest value. And we know that this mean was actually greater than the second highest value. That's why this mean and this A2 is never going to be equal. Okay, and similarly you can see this applies to all the cases. So basically, if you see, we have the lower value here, and the higher value in the middle. Then we have a higher value, and then a middle value and then a smaller value in the middle. So this is the what we are doing. So basically, we have a small value, then we have a high value, then we have a small value, then we again have a high value, and then we again have a small value, and so on. So basically, the mean of these two is going to be small, then the mean of these two is going to be high, which is never going to be equal to this small. And similarly, you can see for all the cases. So all you had to do was, let me show my code. Where's my code? Okay. If you see the code, we have, so basically I took an array of 2 into n, I scanned the complete array, and then I sorted the complete array. Then what I did was, I actually ran a loop from 0 to n. I first printed out the smallest value and then the largest value, then the second smallest value, and then the second largest value, and so on. Okay, so I hope this is clear to everyone. Okay, let me read the chat. Sir, can you please discuss C using DB? We'll come on to C. Okay, it can be easily done by help of a priority queue. I think this is regarding problem C. Sir, I'm in JIT Go now. Okay, that's good to know, Dheeraj. So what if we have very small numbers in left of A1? We can never have small numbers in left of A1. The reason is because A1 is the smallest value after sorting. Okay, Hari, double one is kind of easy, but to get that logic was a little confusing. Okay, it is possible when n is odd. I don't know what Tushar you are trying to say. If a small number. Okay, you are saying it is possible when n is odd. Yeah, exactly. You're right. It is possible when n is odd, but if you see, the problem always has even numbers. Okay, if you see the problem, we have two integers. Okay, so we always have even numbers. Okay, so that's why that case is not possible. I hope A is clear to everyone. Okay, this was an easy problem. There might be many other ways to go around it, but I think this is the simplest way to do it. Okay. Let's move on to problem B, which I suppose many of you want to know the answer. Okay. Okay. Okay, cool. I think A is clear to everyone. Let's move on to problem B. Now, let me just explain the problem first. You're given an integer x. Okay. Can you make x by summing up some integer 11, 111, 4 times 1, and so on? You can use any number among them any number of times. Okay. For instance, 33 equals 11 plus 11 plus 11. 144 equals 111 plus 11 plus 11 plus 11. Ritvik says for B. Okay, Ritvik, I will just explain the approach and then I'll read your comment. Okay. Yeah, I'll discuss your approach. First, let me explain my approach and then I'll tell like what your approach is. Okay, cool. So basically the problem says that we're given a number n and we need to tell if this number is somehow like 8 times 11 plus b times 111 plus c times 4 times 1 d times 5 times 1 and so on till x times 9 times 1. So we have 9 times 1. Okay, there is no like such guarantee, but considering that x is actually less than equal to 10 to the power 9, we can say that the maximum value can be 9 times 1. Okay, not even 9 times 1, 8 times 1. Okay, cool. Here a, b, c and till x are nothing but values which are greater than equal to 0. Okay, so this is the complete problem and I hope everyone like is able to understand the problem. Okay, so if yes, let's just look at these numbers. So the very first thing that you need to notice is that let's see if this n is divisible by 11 or not. If this is, n is 11, then we can say this is divisible and we can say yes. If this n is 111, when we divide it by 11, we get 1 as the remainder. Okay. Now, so for 111 we get 1 as the remainder. For 111 we get 0 as the remainder when we divide it by 11. Okay. For 4 times 1, let's see what is 4 times 1. 4 times 1 is nothing but 11 into 100 plus 11. That means the remainder after dividing this value by 11 will be 0. Now let's look at this value. This value is nothing but 111 times 100 plus 11. Now when we find that its mod percentage 11, this value gives 0. This value we know gives 1. So basically this complete thing is going to give us 1. Okay, because this 100 also gave 1 only. Okay, so the remainder of this is also 1. So now that we know this, and similarly if you see like for even number of ones, if we have like 6 ones, the remainder will be 0. For what, 7 ones, the remainder will be 1 and so on. So basically if you see, we do not really need to care about all these numbers. The only two numbers that are going to concern us is 11 and 111. After that, every value is nothing but a repetition of 100 times of this value plus this value. Okay. So I hope this is clear. This part is clear to everyone. So I'll just remove all these numbers and only keep 11 and 111. Okay. So now we have 11 and 111. Okay. Now there are many approaches to actually go around this problem. Let's start by looking at some numbers. What if we had 110? We know that this is nothing but 11 into 10. Okay. Then we have 111, which is nothing but 111 into 1 only. Then let's have 121. This is nothing but 111 plus 11. Sorry, 110 plus 11, which is actually 11 times 11. Now let's look at 1, 2 and 2. This is 111 plus 11. Okay, maybe some people are able to understand like what is going on now. Let me try to look for 123 as well. We know that we can never make 123 because we know that 121 was possible through 11 times 11. Okay, so with this also we have a remainder of 2, and we could not use this also because with this also we had a remainder of 1. Therefore 123 was not possible. Now if you know, remember 111 when divided by 11 gave us a remainder of 1. Okay, now this gave us a remainder of 1. That's why this value is also giving us a remainder. When modulo by 11 gives us a remainder of 1. What we can say is that if our n is divisible by triple one time, that means it will give us a remainder of 1. Okay, now let's try to look what happens when triple one plus triple one. Okay, now this number is actually equal to triple two, and when we find this modulo 11, this actually gives us what is it going to give us? 110. This is actually going to give us, I think, 2. Okay, this will give us 2. So this tells us that when we divide like any number which was actually a factor of triple one, and if it had 2 times triple one, then this modulo by 11 will give us 2. Okay, cool. Now let's try it for what? Okay, just give me a second. Okay, I think everybody is clear with this. Okay, cool. Now let's see. So we could get a remainder of 2. Can we even get a remainder of 1? Let's see that. So basically, if we had, okay, what number should we take? If we had 110 111 plus 11, so this gives me 3. Okay, let's consider 232. We know that this is nothing but triple one plus what, 10. Okay, and okay, cool. So when we have this number divided by triple one, we actually get a remainder of 10. Okay, which is nothing but when, like, so basically this is nothing but 11 minus 1. Okay, or we could also get 9 here as well. How? So basically when we took, okay, let me just change the approach. Okay, so basically the thing that I'm trying to explain is that whenever we have x number of triple ones divisible by n, then the difference in the mod can be a maximum of like that value. So basically if this was x, then the remainder will be in the range of 11 minus x. Okay, I don't think like many people will be able to understand this. So what I'm actually going to do is I'm actually going to tell an easier approach. And what that does is we first find out that every number after 1100 is possible. How do we know that? So basically we know that 1111 is already divisible by 11. Let's see if there is a way of making 1110. This can be made up by 999 plus 110. So can we do this? Am I right? So basically in order to make this, when we subtract this by 999, we have 1. So we have 111. Okay, sorry. So basically if it is triple one into 0, this is nothing but triple one into 10. So we know that this is also possible. After this, let's try for 1109. This is nothing but 999 plus 110. Okay, then we have 1108. This is nothing but 888 plus 110. And similarly, if we go on till 1101, you will see that this was also possible. So it was possible by 111 plus 110. Okay, so as you can see, every value after 110 has an answer of yes. Okay, so what we can do is we can just say that every number greater than every number greater than 1100 has an answer of yes. Now what about the values below this? For that, what we can do is we can actually write a brute force approach. Okay, and to do that, I'll just make a tree. So basically we know that the answer of 11 is true. We can say that we have two options. Either we can add 11 or we can add 111. Okay, when we add 11, this becomes 22, and when we add 111, we get 122. Now after this, we again have two operations. This is 11, this is 121, sorry, 111, and here also 11 and 111. After adding 11, we have 33. After adding 111 with this, we have 133, right? And similarly here also we have 133 and we have what, 233. So as you can see, the maximum number of steps that we will be able to take here will be 100. Okay, and this is possible. Okay, so the idea is that all you have to do is first calculate the answer of every value till 1100. Okay, and mark it in an array. So let's say we have an array of 1101. Now in this array, brute force. Okay, and for every value, I'll just mark them as like positive, like I'll just mark them if it is possible or not. And after that, every other value has an answer of yes. So what I'll do is I'll just quickly write the code for this, because if I show you my code, that is a little bit different and maybe a little difficult to understand. So just a second. Yeah, this is my code, and I actually did all of this using 1if only, but I don't think it's easier to explain this. So what I'll do is I'll just write another code. Okay, so basically what we need to do is we have to first create an array of 1101. Okay, now in this array we can first let's memset this. Okay, let's make this array global. Okay, array of 11 equals to 1. Okay, now all we have to do is 1101 I plus plus if array I. Okay, we cannot make a global array with ARR. If array I equals to 1, then we can just write array of I plus 11 is also equal to 1, and array of, okay, this needs to run from 11, array of I plus 111 should also equal to 1, and that's all. So basically with this for loop, you will actually be able to generate the array of 1101 for all the possible answers. Okay, now after scanning this, you just have to do if n is greater than greater than equal to 1101, the answer is always yes. Okay, else if ARR n equals to 1, then we can just print yes, else we can just print no. Okay, I hope this is clear to everyone. Okay, so all I did was I actually generated the array of 1101 till 1101, like how many values are possible out of these, and after that we could say that every value is possible. How do you say that if x is greater than 1100, it is always possible? Okay, the way I say this is that let's try for value 1111. Okay, this is yes, because this is nothing but this is divisible by 11 only. Then let's say for 1110, sorry, 1110, this is nothing but 111 into 10, so this is also yes. Then we have 1109, this is nothing but 999 plus 110, and this 999 is nothing but 111 into 9, and this is 11 into 10. Similarly, 1108 is actually going to be 888 plus 110. This is 111 into 8, and this is 11 into 10. And similarly, we can go on till 1101, and every value will be possible. Now, if 1101 is possible, that means 1112 is also possible, because this is nothing but 1101 plus 11. Okay, so with 1101 we can say 1122, 1112 is possible. Then with for 1102, if we add, so if this is possible, then we can just add 11. We can say that 1113 is also possible. So as you can see, after with this we can say that every value will be possible after 1100. Okay, so I hope this is clear to everyone. Okay, so this is the easier approach. I also like the code that I did, and this is the code for that. Okay, you can just look into this code, and okay, I'll just show my code as well. I don't know how many, so I actually wrote a different code, and it's a little hard to explain, but yeah, you can check this out as well if you want to. Okay, in this what I'm actually doing is I'm actually finding how many times I was able to divide n by 111. Okay, and then I'm just like assuming that my answer can actually vary in the range of that many times when I take its modulo 11. And actually geothermal also wrote the same code in a different manner. If you see, uh, let me go to my friend standings. And geothermal also wrote a very nice code, which is actually nothing but a variation of this particular logic that I have written. Okay, so you can check out his code as well. This is a very nice code, I would say. So you can check out this code as well. Okay, so I hope with this everyone now knows how to solve problem B. Can I have a yes or no in the chat? So basically this was the only trick. All you had to do was find, like, after 1100 every value is possible. Okay, so can I have a yes and no from people in the chat so that I know like they were able to understand? If yes, you can just like the video as well. Or if you are still having any problems, I actually have my Discord link in every of, just a second. Okay, yeah, I have my Discord link in every submission. So, okay, this does not have. If you look at this code as well, I have my Discord link at the top. Where is it? Okay, it's here. Okay, so you can join this channel as well and ask me all the doubts there. Okay. Okay. I don't see any yes or no's. Like, is there any lag? I think there is some lag. Okay, I see yes now. Yes, why not greedy algo? Anubhav says greedy, actually geothermal did a greedy algo only. Okay. This is brute force. Geothermal wrote a greedy algorithm, and what I did was something on the lines of greedy only. Okay. Let's move on to problem C1, C2. Okay. So I'll just rub all of this. Shashank says, why greedy didn't work? The reason why greedy doesn't work is because we have x till 10 to the power 9 and we cannot run a for loop till 10 to the power 9. Okay. This will give us a TLE. That's why like the greedy was not able to work. So Roop says, any other approaches? I have told two approaches and I can say that the very first approach is very easy. So I don't think there are any other approaches. Okay. Now, Vishwesh says, can you use DP in C? I could use DP in C, but there is no point of using that. I'll explain why. Okay, so what you are actually going to do is we are going to directly solve C2 because the idea of this problem is very, very simple. Okay. I myself like thought many different solutions for this and then I finally got accepted, and all these solutions, if you see, are actually very big. Like before this, if I show you my second submission, it is a very big submission. Okay. I did many things in this, but the final submission is actually of like 10-15 lines only. It's a very simple idea. If you see, this is the complete logic of the last problem, the third problem. So let me quickly explain like how to do this. Okay. Now, if you see, okay, so the problem is that there are n portions and lines. So basically we have, how do we say, A1, A2 till AN. Okay. With portion 1 on the far left and portion n on the far right. That is how we have drawn. Each portion will increase your health by AI when drunk. Okay, so basically every portion will increase our health by plus of AI. Okay, when drunk. Okay, AI can be negative, meaning that portion will decrease with will decrease with health. I think they should be with health. Okay, so basically if it's negative, if AI is negative, it will decrease. If AI is positive, then it will increase. Okay. You start with 0 health and you will walk from left to right. So basically we are going to walk from the left to right, and initially our health is 0. Okay. Okay, left to right, from first portion to the last portion. At each portion, you may choose to drink it or ignore it. So basically when we are at A1, okay, right now our health is 0. If this is negative, let's say, then we will choose not to drink it because we know that after drinking this, like we cannot drink this because our health will become negative. Okay, so what is the largest number of portions you can drink? So let's like take the first example only. Okay, so if you look at the first example, we have 4, we have -4, we have 1, we have -3, we have 1, and we have 3. Right now our health is 0, so our health here is 0. If we, since the very first value is a positive value, we'll obviously take this. Okay, so we'll add +4. Now the next value is -4. We can take this -4 because after taking this -4 our net health will be 0, which is considerable, which is okay right now. Okay, but if this had been -5, we were not able to take this. But after this 0 we can take this +1, our health becomes 1. But after that we have -3 and we cannot take this. So basically till now we have taken 4, we have taken -4, we have taken 1, but we cannot take -3. So we move on to the next one which we can take. So now we have a sum of 2, and then we have, this should be -3. Yeah, we have -3. Now this -3 we cannot take because after taking this our health will become -1, which is not possible. Okay, so if you see, the maximum portion that we took here was 4, but there is another approach. If you actually leave this -4, if you take this 4, then you take this 1, our health right now is 5, then you take this -3, our health is 2, then you take this 1, our health is 3, and then you take this -3, our health is 0. Okay, so yeah, that is the complete thing. So we took this, and this. So basically the maximum number of portions that we could take were 5. Okay, so now let's just arrange the data. Let's try to think of this as a general problem, and let's say we had some positive values here, then we had some negative values here, then we had some positive values here, and then we had some negative values here. Okay, now the very first thing is we always take positive values. We always take positive values. Okay, because every positive value is actually going to add up to your health. Okay, that's why it's always beneficial to for us to take the positive values. Now let's see about negative values. Okay, let's say that you randomly picked any number out of these. Okay, any, like, let's say any like x number of portions, you took any x number of portions. You do not know what all portions you took right now. Okay, but what you know is what all portions you took. So basically what you have is what do we say, a set of all values that you took. Okay, now let's say that after this point we actually, let's say after this point our health here was what, h. Okay, now let's say this is something which is greater than -h, greater than h. So basically if you take this portion, the health will become negative. We are able to see that. What you will do is you will take this portion. Okay, your net health is negative right now, but now you will try to, so basically there is a possibility that, let's say this health was 5 here and this negative value was -6, but there is a possibility that some time back you took -7 as well, but here you were able to take because your value was greater. Okay, what you will do is you will actually take this -6, your net health will become -1. But now what you'll do is you'll actually take a note of what all negative values you have taken. So you know you have taken -6, you know you have taken -7, you have taken -6, you have taken other values as well. What you will do is you will take the largest negative value. The largest negative value is -7, and you will remove that value from your health. So basically if you remove this -7, so you'll actually have to add this -7 because you have already consumed this health. Okay, so this will give you a 6, which will actually tell you it's better to take this health of -6 and remove this health of -7. Okay, now the very first thing that I should tell is basically, if you see in the hard problem, n is actually till 2 into 10 to the power 5. It is 2 into 10 to the power 5. What this tells us is that there is no DP possible for this. Okay, there is no like way of like thinking of a DP because we either have to go for a n log n approach or n root n approach, and n log n and n root n are not even considered for this question. Okay, so the only approach that will work should be of O of n or n log n. Okay, and that is only possible through a greedy approach. So like DP is out of the picture. So all the people who are actually thinking like we could solve C2 by DP, we can solve C1 by DP, But yeah, the idea of C2 is very much simpler than C1 actually. So, okay, so the approach is greedy, and what you have to do is you'll actually keep on adding the values whenever you have, and whenever your total health becomes negative, what you will do is you'll actually see how many what all negative values I have consumed till now. Then you will pick up the biggest negative value from your set and remove that value from your health, and now see if your health is positive. If your health is positive, you will try to move forward again. If your health is negative right now, you'll again move the second highest, like most negative value from the set, and you'll remove that from your health. So if I try to show the code, so okay, I not copy? Yeah, okay. So basically what I'm doing is I actually have this array which is negative. This is a multi-set actually, not an array. In this multi-set, I'm actually inserting all the negative values that I have consumed till now. After that, I've just scanned this array. This is count. This counter will actually tell me the number of portions in the end that I have consumed. This is the sum that I have till now. Okay. So what I'm doing is whenever I get a negative value, I just insert this into my negatives multi-set. After that, what I do is I add my value. I do count plus plus because I even consume this negative value as well, and then I try to remove the values. Okay, so for removing, what I'll do is I'll see till when is my health negative. Okay, so if my health is negative, what I'll do is I'll actually take the biggest value from this multi-set. So since multi-set actually sorts the value from like lowest value to the highest value, and I'm actually inserting the -1 into this. Okay, okay, so I'm actually inserting the -1 of this. So basically I have to take the very last value of this. This is the set, this is the lowest value, and this is the highest value, highest negative value. So I'll have to take the highest negative value. So what I do is I actually take that value and I add that to my sum. Okay, since this value, okay. So what this does is this actually adds some health to myself and removes the largest value from my set. Okay, and I do a count minus minus. So basically the idea is that you consume the value, then see if your health is negative. If it is negative, you remove the highest negative value. Okay, and that's it. So basically, because that is what makes sense. If you consumed any value, if this was the highest, it will automatically remove this value. If this was not the highest, it will remove the other highest value. Okay, so idea was very simple. I myself thought like many different ideas. Maybe we have to think for the forward values as well or anything. But in the end, if you see, this actually makes a lot of sense. You take all the values and then you try to remove all the negative values. Okay. I think the deep. Okay. Okay. I hope this is also clear. Can people tell me in the chat if they are clear with the approach? Sir, X is large. We cannot make it. What do you mean by X here? Manjula, I am not able to understand like what you mean by X here. Is X anywhere written? No, X is not written anywhere. Okay, is there anyone who still has any issues with this? Sir, but what if largest negative value was at the end of the array? What choices have we made for the lowest negatives? Okay, Hari Krishnan. So basically, if the highest negative value, let's say this was -8 only. So we will first add this to our array and then we'll remove this also. Okay, with that, like we have, so basically this is a very general logic only. So you first add the value and then try to remove the highest negative value. Okay, so even if this is the highest negative, that's okay. Okay. Please tell DP solution of C1. DP solution is a little messier, so I'm not going to tell that, and I don't think that's useful even because we can solve this using greedy. Okay, so let's not waste time in that. Okay, is there anyone who is still not able to understand? If not, everybody is able to understand, I'll end the stream because so it's okay if you are not able to solve much problems today because every problem was like a little tricky. But yeah, I would say this was one of the very good contests, okay, in which the problems have an actual logic behind them. Okay. Cadence algo, no, this is not really a variation of cadence algorithm because in this we actually can take a subsequence. We have to take a subsequence, not a subarray. Okay. Okay, cool. Okay. I hope everyone is. Rishabh then says one question. Okay, Rishabh, what is your question? Okay, I hope this is clear to everyone. How can we be sure highest negative value needs to be removed? Uh, because you have a total sum in the bag and you want to, like, let's suppose this question. You have a very large bag, okay, and it is very heavy, okay, and you need to like make this light. So the only logical approach is to first remove the heaviest value. Here, heaviest value is actually the most negative value which is decreasing your health, okay. So that is why you took the highest value from the set and you remove that, okay. To remove the largest negative value, that will take n square time. No. So basically, you can use a multi-set for that, and multi-set will remove the value in log. It will tell you the value in login, and then you can remove the value in login time. Okay, and the reason you have to take a multi-set is because there might be multiple values as well. As in the very first example, also, if you see, we had -3 two times. Okay, so that is why you actually need to consider a multi-set. Okay. Okay. Shashank says, can you discuss problem B again? What you can do is you can just go back in the video like 10 minutes before, 15 minutes before, I think, and you can watch the solution. Okay. Irrespective of the position, how position doesn't matter. I'm not able to understand, Rishabh, what you are trying to mean here. Yeah, got it. Shashank says, got it. Okay. So as we can see, today's problems were today's like problems were very simple. Okay, but they had a very like good idea behind them. Okay. What's R begin, sir? R begin is the reverse of begin. So basically, if the beginning, like begin means the beginning value, R begin means the last, the value from in the beginning from the last. Okay. So if this is a set, R begin will point to the last value and begin will point to the very first value. Okay. What is okay without multiset? Without multiset, we can also use a priority queue if you want, but yeah, multi-set is better, I think. Okay, so says lead code contest also consider into discussion if possible. I am actually kind of thinking to like include lead code daily beginner contest in this as well. Let's see if many people want that. You can just tell me on the Discord and I will like start streaming them as well. Okay, anyways, I think that's enough for today. I hope everyone is clear with A, B, and C1 and C2. Okay.